So as you can see here, we have a genetic cross for ferrets. In the top left, you can see the fur color with black and white, black being dominant, white being recessive. Their demeanor, playful being dominant, mean being recessive, and their tails, striped being dominant, and solid being recessive. So if you look here, big B for black, little b for white, big P for playful, little p for mean, big S for striped, little s for solid. If we go over here, we can look at our crosses of the parents. So parent one's gonna be homozygous dominant for the first trait, homozygous recessive for the second trait, and homozygous dominant for the third trait. And we just have the inverse for parent two, homozygous recessive, homozygous dominant, and then homozygous recessive. So that means if we go over here to our cross, this is the only possible phenotypes. So all the F1s are gonna be all heterozygous for each trait. As you can see, our genetic images right here, big B, little p, S is gonna go here, and then parent two is gonna give little b, big P, little s. So if we go down and look at our genetic map for our cross, we have black, mean, and striped crossed with white, playful, and solid. Our R1 is going to be 0.08 because we have 8 centimorgans right here. R2 is going to be 19 centimorgans, so we're going to have 0.19, and our coefficient of confidence interval is going to be 0.89. As you can see here, we have all 8 phenotypes. Going to have the 2 no crossovers, the 2 single crossover ones, single crossover 2, and double crossovers for a total of 1,400 progeny were observed. If we go over here, what are the chances of having a white, mean, and solid with a double crossover? So here's our formula for that: 1/2 of recombinant site 1 and recombinant site 2 multiplied by our confidence interval. So we plug it all in. We get 0.006764. It's the probability, which comes out to 0.676% of progeny will be that. And then chances of black, playful, and solid is a single crossover 1 event. So here's our formula: 1/2 of all the recombinant ones minus our double crossover event. So you go ahead and plug it into our formula, and we get 0.0366, which comes out to 3.66%. As you can see over here as well, you can see the expected amounts I did instead of, because we don't have an actual study. So instead of as observed, I worked backwards and got my expected amounts. So here they are. And as you can see, we have the 2 no crossover events, 2 single crossover, 2 single crossover 2, and the 2 double crossover. And my citations will be down in the YouTube description.